Hello everyone, today let's take a look at QP86. There's a bunch of different ways to solve this, but basically you roll 3 dice one by one, so what's the probability of obtaining 3 values in strictly increasing order? So strictly increasing order, that means something like 1, 2, 3, or 1, 3, 4. You couldn't have something like 2, 2, 3, for instance, because that is increasing, but it's not strictly increasing because these are equal. So we have 6 possible values that any dice could take, and for it to be strictly increasing, we need 3 of them that are not the same. So what are the number of ways we could get 3 different values from a group of 6? Well, we have 6 values and we're choosing 3 of them, obviously. And now for every single subset of 3 that we choose, let's just say it was randomly these 3, there's only going to be one way of arranging them such that they are in strictly increasing order. So 6 choose 3 is equal to 20. For each one of these subsets, we have one valid way of arranging them that satisfies our condition. The total number of ways to roll 3 dice are, well, we have 6 values for the first dice, 6 values for the second dice, and 6 values for the third dice. So when we multiply those, we get 216. So our final answer should be 20 out of 216, which is equal to 5 on 54. Another way we could have solved this was just by using conditional probability. So if we condition on the fact that we need 3 different numbers for them to be strictly increasing, well, the probability of 3 strictly increasing numbers is going to be, well, I have 6 choices for this one, and then once I've chosen a number here, I have 5 choices for the next and 4 for the third. And I have 216 total ways to roll 3 dice, so it's going to be 6 times 5 times 4 on 216. That's the probability of us getting 3 different numbers. And now that I have 3 different numbers, what's the probability that they are in strictly increasing order? So if I take the example again where I have a subset of 2, 4, and 5, well, there's going to be 3 factorial ways to permute these numbers right here, and only one of them will give us a subset in increasing order. So 1 out of 3 factorial, which is equal to 1 out of 6. So this right here was the probability of us getting 3 different numbers, and this over here was the probability that these 3 numbers are strictly increasing when we condition on the fact that we have 3 different numbers. So obviously when we multiply these together, it's just a basic rule of conditional probability, we get the probability of intersection, which in turn is just equal to the probability of strictly increasing in general, because strictly increasing is a complete subset of this over here. So now when we actually multiply these, the 6 is going to cancel right here. And again, we're going to get 20 out of 216, which again is equal to 5 on 54. So that's just another way of solving it.